Good evening, everyone. After a long time, we are just moving forward in the Kubernetes. During this period of time, I explored much about Kubernetes. Okay. For running a proper Kubernetes system, so just I will take it as a full screen. So, so if you want to run a Kubernetes on your desktop, on your PC, basically, then you must have the sufficient RAM required. If you watch my previous videos, my voice is clear, Vedant?
Yes.
Okay, okay. So, wait a bit. So, so yes. So if you want to run a Kubernetes on your desktop or your PC, then you must have a sufficient amount of RAM is required on your PC. If you are running with 8 GB RAM and that's must like sometimes the Kubernetes nodes or a cluster we can say are not successfully created. Okay, so are not successfully created, and you if you have in trouble, like your system may be not handle these much level of task or this virtual machines. Actually, if you are running a particular node on your like PC, then your PC must be segregated in a way that a virtual machine created on your PC and a virtual machine that must require some amount of RAM that is required for your uh, for running a virtual machine, a virtual server on your device. On that virtual machine, a particular node is running. So that these all things are required some amount of RAM. So my laptop must not be handle that much level of RAM. That I understand after performing some task that RAM is not sufficient on my device. So that is the reason why Kubernetes Minikube is not running on my device. So after knowing that what is the reason why Kubernetes is not running on my device, I just extend my RAM and got that the Kubernetes is successfully running on my device. If you want to see, then just see it. Yeah. Wait, firstly close it the previous session. So I will explain later on what is Minikube. And if you are going like basics with the Kubernetes, then firstly watch the first, second, and the software required part for your desktop to run a Kubernetes and to understand the complete knowledge of the Kubernetes, which is required to deploy to make a cluster. That's the basics. The master node, what is the worker node, was the kubectl, kube proxy, API server, storage manager, etc., etc., etcd, and all of the things that are required to know, because basics are the fundamentals that are required for making complete full cluster. Okay, so if you want to see it here, just the status, what is the status of the current Minikube. So if you write it here like this, so here you like the control plane and host is stopped, everything is stopped right now. Actually, I don't run the previous command, which is required because whatever I end in a software requirement part of Kubernetes, that is sufficient. If you go with the on the entire video, at the end, after performing all the tasks which are like I explained uh, in that video, in my system the Minikube is not running because the RAM is insufficient. If your system has a sufficient amount of RAM, then it must be running. Okay, so it must be run on your device and you were not getting any trouble. So if you are seeing here and go to the memory section, here you see 57% are okay catering. Okay, so RAM is 57%, 8.8 GB. I extended actually at the starting portion. My RAM is uh, 8 GB only, and after the extension, it will increase to 15.7. Okay, so just if nothing is required, I just want to like erase it. Wait, wait a bit. Okay, so all the tabs are required. Okay. Okay, so if you close the multiple, if multiple tabs are open, then the RAM is also consumed. Okay, random access memory. So here in use the 6.0 committed is, and the thing is, I I explained that this must be extended. Okay, so my RAM is extended, and now you see that 56% are full. So if I run, wait a bit. So see, so okay. So my CPU and the memory 56% is visible, Vedant.
Yes.
Okay. So like this time you not informed me that I will always sharing on my screen on the PPT. But okay, it not whatever I explained is the basics. Okay. So here you can simply see that 56% are the percentage which are like acquired by all the Zoom and PPT and whatever I have running in this that is like kit that is required, that is acquired by all these tabs. Okay, so wait, okay, so here you can see 55% are acquired. Okay, okay, so just I go it here, and actually you can't able to see previously because I'm not sharing the entire screen. Now I'll be sharing my entire screen, so you will clearly see that Minikube status is a host is stopped, kubelet is stopped. Kubelet, what is kubelet, kube proxy? I will explain all the things in my previous sessions, so I'm not taking all of these stuffs in right now because I have to move forward, and it is the Kubernetes part 4. So if I just start Kubernetes, you see what is happening in the memory section. You see clearly that the containing storage, which is previously 56%, is right now 78%. Okay, because a virtual machine is running and it acquired some amount of RAM, and 12.3 and like upon 15.7 GB is acquired. So 78% is required, and now my minikube is not started. So we'll wait for a second, and like it is increasing 78 to 79%. So you see clearly that inside the Kubernetes, a Docker is by default a container runtime. We have actually more container runtimes available. Those are container D and CRIO, container D and Docker. We use also CRIO, and on that case, you must be implement some other commands for running. So you clearly see the CPU utilization is also increased. The memory utilization, that is the RAM, is 56 to 78 directly move. Okay, so you from here you clearly see done. Kubectl is now configured to minikube cluster and default namespace by default. Okay, so till here, if you have any doubt, Vedant? Okay, so I think all the stuffs are clear why a minikube is not
No,
running.
no doubt.
Okay, okay. So I think Actually, you are able to see my screen command line, and whatever the thing is going on screen is visible, na? You can clearly see 78%, Vedant.
Yes.
Okay, okay. So the thing is visible. So from till here, you will clearly understand why kubectl. What's the main thing that is why that's not running on like a simple PC with the 8 GB RAM. So here the 78% is acquired, and now we are moving forward on our PPT. So I clearly explain why this is not running previously. Okay, so just close it here and we go through with the PPT. So it is our Kubernetes part 4. And what is Minikube? Firstly, Minikube is a lightweight K8s implementation designed for local development and testing purposes. It creates a single node Kubernetes cluster on your local machine. Minikube supports multiple operating systems and allows you to test Kubernetes features without requiring a full cloud environment. It's an ideal for learning Kubernetes or prototype applications. Sorry. So Minikube is a lightweight K8. So what is Minikube? Minikube just a local environment. Like it is not an actual cloud, but it is used for testing purposes. It creates a single node, and that node is work as a master and a worker node both. So Minikube creates a single node that work as a master node and the worker node both. So it is a lightweight implementation. All of the things are mentioned it here, and you can clearly see. So here you can clearly see Minikube start with the driver virtual box. Actually, in my case, if you see the command line, so it is here mentioned that I will using Hyper-V virtual machine for running a Minikube. So so here you can see failing to connect. This is from both inside a Minikube virtual machine and host machine to pull external images, preparing. And what is this configuring bridge CNI? Container networking interface. What is CNI? I'll explain in my like in the next slide. What is CNI basically? These all the things are related to the container. So I'll explain it. So what is the namespace, etc., etc. At this time, you just write Minikube status. Just see what is the thing. So you all think that control plane host is running, kubelet is running, API server is running, and kube configuration is running. So here all the things are stopped. Minikube start command just it will started all of the stuffs, like all of the services basically used to communicate with the nodes, particular nodes on the cluster that is available on a Kubernetes. In this period of time, like this time only Kubernetes is running and a single node is running. So what is Minikube? You understand that it creates a single node that's work as a master and basically worker node both. So here a CPU or some amount of RAM it will be acquired, and it supports multiple operating systems allowed to test Kubernetes feature. Okay, so all the things here. So what is computer network interface? Is a standard for configuring network interfaces in Linux container. It allows container orchestrators like Kubernetes to manage container networking, ensuring connectivity and the resource isolation. Okay, so computer network interface is a standard configured is basically used to configure the interfaces between containers and the container uh, basically it is used to configure the Linux containers and merge with the container runtime. Okay, so sorry it is used to configure containers to a network. Okay, on that these containers must be running with the help of that network. It used to connect containers to a network. Okay, so network is a standard configuring network interfaces in Linux containers. It allows containers orchestration like Kubernetes to manage container networking, ensuring connectivity and resource isolation. So whatever I tell now, it basically connects to like containers to a particular network. So checking status, this is a simple command, minikube status. So what I take this image from source, I take this image from scalar site. So here, this image, you will be clearly seeing there is a CNI. Okay, all the containers CNI have some parts: loop, back, bridge, flannel, uh, calico, and cilium. Cilium. Okay, it's cilium. I think wrong character mention here. These are the third parties and the built-in types. I will explain each of them, and it will basically connect to CNI. And CNI, with the help of container runtime, it will both manages the entire up portion and entire the inside portion. So containers, CNI plus container runtime, it basically connects to a particular network on that these all things are running. So we are moving forward. So what is the loopback? Loopback is a basically plugin in CNI, provides a loopback interface inside a container. So it basically provides an IP inside that container. It ensures the internal communication within the container itself. This is an essential for processes within the same container to interact seamlessly over the network. Basically, I will tell you that basically containers are connected to a particular network. So inside the container, a particular IP is mentioned, and on that IP, it will be connected to a network. Okay, so this with the help of loopback, an IP is mentioned inside that container, and it ensures to internal communication also. So what is bridge? Bridge creates a virtual Ethernet bridge to connect multiple containers on the same host. Okay. If you want to connect with the same host, multiple containers, it allows containers to communicate with each other and with the external network using network address translation. Network address translation is basically used to connect to IPs. Okay, so if you are in the sixth semester, you will study network address translation on some units in the BTech. You will study NAT. Okay, in the second to third unit, it is there. So bridge plugin is basically used to connect multiple containers to a single host. Okay, same host communicate with each other in an external network. So सेम होस्ट के लिए ये हो गया और पर्टिकुलर आईपी के लिए वो हो गया और पर्टिकुलर नेटवर्क के लिए. Flannel is a tool that helps to connect containers running on different machines. It creates a virtual network so all containers can talk to each other even if uh, Flannel is basically used when the containers are running on different machines and they want to talk to each other, like communicate to each other, forwarding some requests, some other things. So we are use flannel. So bridge loopback is basically IP. Bridge is to the same host, and flannel is a virtual network that connect multiple container inside it. So Calico is a third party basically and is a networking tool that connects container across different machines and also provides a strong network security. This basically used for the security purposes, and it allows to set rules, policies to control which containers can talk to each other. Particular restrictions are used, are applied with the help of Calico. So what is Cilium? Cilium is a networking tool that use eBPF. What is eBPF? Extended Berkeley Packet Filter is a technology that with the help of this technology, we can run a simple program inside the Linux kernel that allows running custom programs safely at the kernel level, and it enables advanced networking security performance measuring without changing the kernel interface. eBPF is highly efficient and widely used in tools like Cilium, Falco, and VCC for modern observe. So it is a tool basically how we can optimize it, how we can enhance the security, advanced networking, and not taking much time. Okay, so we use the Cilium is a networking tool that uses eBPF to connect containers and provide fast scalable communication. It also offers strong security by controlling and monitoring network traffic between containers. So Cilium and Calico is basically what third party third-party tools, and Flannel, Bridge, and Loopback is basically a built-in tools. So it is uses eBPF, which is the extended back Berkeley packet filter, which is an important technology that enhances advances networking, security, and performance monitoring without changing the kernel itself. Basically, simple programs are running inside that kernel, and we are moving forward. So process to connect Kubernetes node. So how we you will get this type of interface? Basically, for connecting any server, SSH protocol is needed. For connecting any remote server or physical server or a virtual server, you have to be firstly, I will open the command line. Okay, so for connecting any of this tool, we require the SSH protocol. So Minikube status firstly will check to check a virtual machine or virtual thing server or running or not. So all of the things are running completely. So just write Minikube SSH. We have another tool, like firstly we will go with the password and the Docker. So firstly we'll check what is the IP of our Minikube. So this IP, remember this, I will be showing this IP on some parts of our slides. So Minikube have a particular IP assigned. So just we are going inside that node. So here you can see Minikube, we are successfully entered, and here Minikube is written. And we are inside that, it is showing by this dollar symbol. And so here basically a process to connecting for any server SSH protocol is needed to connect, right? Minikube SSH inside the Kubernetes node. The default container runtime for Kubernetes was Docker, but Kubernetes now supports other container runtimes such as CRI or containerd, which are commonly used as alternative. So basically Docker provides a container runtime. Inside that container is based on some images, and container are basically containing a processes. So we have another container runtime also, like CRIO and containerd, which we will be using for basically running our containers. Okay, so by default, containers started when running a node on Kubernetes can be viewed using Docker PS, including system containers like kubeproxy. Okay, wait. I will be running all of the steps. So firstly, you will write what Docker PS, how many containers are running. So here you can clearly see I will be nothing run any containers. So if you are inside that cluster, then some amount of containers are automatically run, like a storage provisioner, like this nginx I will be previously running. So it is not by default. So what the cube system, okay, cube systems, and what manager controller, cube controller manager, API server. Okay, API server, and queue proxy, storage provisioner, proxy, queue proxy, and scheduler, control manager. All of the stuffs which are required for a particular master node is basically running at this point of time. So we are seeing simply that clusters, inside that cluster, when we start a minikube cluster, then some amount of containers are automatically running, and we are completing, like by default containers started when running a node can be viewed using actually when you start, you have a minikube, you just started a minikube, a single node is running, and inside that node of that is work as a master and the worker node. In the inside that master node there is particular qualities like API server, queue proxy, kubelet, and all controller manager and all of the things. So it is running by default. So we are just moving forward. So what is kubectl? Actually, I explained him previously also. So kubectl, if you just write it here, then here kubectl is not working because it is the external tool to communicate with the Kubernetes cluster. You inside that Kubernetes, you can't be use the kubectl. If you want to use the kubectl, then you have to write like I think one slide is missing. Actually, it is on the next page. So firstly, you have to be exited. Wait. So here kubectl is not available inside the Kubernetes. That is the external tool you use. used to interact with the Kubernetes cluster. Now, if you want to run a kubectl, then go outside of the node and the cluster. So you have to go outside, just write exit from here, and you are simply c log out. So you are not on the cluster inside that. And this time, if you write kubectl, so simply clearly see and all of the things, basic commands, and what is kubectl. Kubectl controls the Kubernetes cluster manager. Basically, it's a outside controller. So if we write kubectl cluster info. Mhm. So here a Kubernetes control plane is running is this IP 172.13.31.4.130. Clearly see, this is the same IP in which Minikube is running, our single node is running. So with the help of this kubectl on my device, kubectl will interact with this IP 172.13. Uh, uh, 4 point this is particular name. If you want to, like, I think this time, wait, it may be run. So this time nothing is shown here. So I will be showing what is the dashboard for Kubernetes after some time. So here Q core DNS is also processes that containers is also running. So if you want to see that here something is mentioned and core DNS is mentioned here, it takes a lot of time. If I want to just check what where the core DNS, just wait. If we just uh, check, maybe we are not taking much of time and we are just Minikube or ps, wait, docker ps grep either core DNS. So here you can clearly see a core DNS is running and a pause is running. Pause is basically used, uh, it is associated with namespace, with every namespace. Wait, so it is associated with every container because it is used to handle the namespaces. So we are just moving, only 10 minutes are left. So just we are taking a forward way. So just right from here. So you are really clearly see that core DNS is also running and control DNS is also running. With the help of kubectl, we will understand it. So just hit here for checking the IP of the node Minikube IP. You will clearly see that Minikube IP and Kubernetes kubectl cluster info will be returning same IP. So you will clearly understand the kubectl. This is directly connected to the Minikube IP. Minikube also provide the kubectl tool. You can run, for example, Minikube kubectl dash cluster info. Actually, I taking this image from a like free code camp. So just we wait here. If I write, wait, wait. Okay. So for getting the status, the number of nodes are running, how many number of nodes is running. So firstly exit from here, and we are going to kubectl cube let get nodes. So how many nodes are running? Kubectl, sorry, kubelet. I asked a service name. Kubectl get nodes. So here a Minikube node is running. I mentioned it that it is working as a single node is running. Minikube will make a single node, and that node must be like working as a both worker and master node. So just write cube node get pods. How many pods are running? So hello and nginx, two pods are running. Actually, I will starting two pods in the at previously of this session. So just hello is also based on a hello is a basically name, but hello is a container name, but it is based on like it is based on a image that is nginx, and nginx is also a container based on nginx image. So kubectl get pods will get you basically these hello and nginx is a pod name, and qcl get namespaces. Namespaces are used to basically segregate the configuration and some portions of the Kubernetes. So here the default namespace cube node lease cube public and cube system are the namespaces. Okay, so if you want to get these all are running in the where in the default namespace. So if I want to run, if I want to know what is inside this, wait, so just write cube system. I think some command is wrong. So what is get namespaces? Okay, okay, get pods namespaces. Okay, so command is I think wait cube system unknown namespace. Okay, okay. So that's my fault. Wait a bit. Wait, wait. So here cube get namespaces. Actually, what namespace? So here you will be clearly see that inside the cube system namespace, these much level of pods are running. So storage provisioner, cube proxy, cube control. These are the essential for a Kubernetes cluster work as a master node. So just we are moving forward, and for creating pod, we just write kubectl run container name and image based on that. So just write a kubectl run, or what is the container name? If I want to run a Redis image, just write Redis image equal to Redis. Okay, so I think something is wrong here. Space is not. So here a pod Redis name that's named the Redis. Actually, you know that name are not the same one. This is essential in Kubernetes. Name are not the same. Name same नहीं होना चाहिए, which whatever the name of image, the name of pod must be different. So inside the particular pod a particular container is running. If you write the docker ps, so okay, so we are not inside the mini cube, so just we not write this. And if you write cube ctl get pods, firstly ctl get pods, wait wait a bit. Okay, so if you write you shall get pods. So here you can clearly see that NGI Redis is also running. Sometimes it will take some amount of time to run. Basically, it pod is starting per node per pod, and per container is our conventional name. So it's taking some amount of time, but here clearly it will be started successfully. So just hello is a pod name, and that is the simple command. If this time if you want to see where the container is running, I want to see, just write the Unicube SSH protocol, and we are login inside our the network. inside our cluster. Just write the docker ps and here grep and whatever the our name container name is, what redis. So here you can clearly see redis is also mentioned and pause is also mentioned. Pause is useful for taking a default namespace, and redis is basically like container which is running inside the kubernetes, and inside that kubernetes a runtime docker. So that redis image, that docker container is running inside that docker. So we just moving forward, and that's the simple thing. Here the pause, here the pause useful for taking condition of namespace. Okay, for writing the command going inside the container. This time you are not inside the container. So if you are moving want to inside that container, you just actually uh, uh, firstly we are on the mini queue, huh? So it is very easy. So just what, docker exec slash it. So what is this ip?